This is the 2020 pre-higher level question 5, the transformation geometry question. I'm just going to go through this, work our way through the solution. I'll explain as much as I can about it, what difficulties you might encounter, and ways that we can solve them. So we're just going to have a look at the question first. The figure shows a logo based on a regular hexagon for a stove and heating company. The logo is subject to transformations in the following order: axial symmetry from P to P1, translation from P1 to P2, central symmetry from P2 to P3, and a rotation clockwise about point O until point P3 reaches the line OL. So this is different to some of the other ones that we have done. We're not asked to find the center of rotation, we're already given it, so all we need to do is rotate it around the specific point that we're given. So as we can see there, we're given the information for the question, how we're going to set it up. Part A of this is to draw the given figure, so that's setting up your hexagon with point P, the chimney piece on it, and then locating all of the other points necessary. Part B is to determine the image of the logo under each of the above transformations, and then just a final note, all geometric constructions must be clearly shown on your drawing sheet. So we're going to just have a look at setting this question up now. So the first part of this is based on a hexagon with a chimney coming out of it. And unlike most questions, I think for this it's easier to start by drawing the hexagon first and then locating point P afterwards and locating all of the other points then. So if I have a look at my page, I've put my start point up here, and that start point is going to be the top of the hexagon. It is not point P. Just as I think it'll be easier to set up the question doing that first. Right, this is a regular hexagon and each side is 36 millimeters long. So the angle that we have up on top there is going to be based on 30 degrees. So I'm going to take a line of 30 degrees from either side. And I'm going to measure a side length of 36 millimeters. I'm going to copy this length with my compass, just quicker, and mark that out each time. I'm going to do the same for the remaining sides, so it's vertical in this case. Again, we're given two 36s, and finally meeting down in the center. Giving me the basic hexagon shape. Now I can darken in each of these lines here. The only line that I can darken in all of it. So this is the outline for the hexagon. The next part of this will be to locate the parts in the center, the curves, as we'll need them to locate the position for P up top. So for here, what we need to do is we need to join a diagonal line across from here to here, and then from two other points. So I'll just label my points before I do any more. So I have A, B, C, D, E, and F. I've joined C and F together, C and F, and I'm just going to join B and D together also. A and E also need to be joined. Now if you look at the question, you will see that what I'm doing there is I'm finding the start point for those arcs. I don't know the radius. I have the center point, and I now have two end points on it also. So the center point is going to be halfway along the line DE, so 18 mil. And my start point is going to be here. Do the same from the opposite side. I'm just going to transfer it up here. And that gives me the piece in the middle. From here I can then find point P. Okay, so if I draw a line joining my center points, or the center points of the arc, where that intersects the second arc that I draw, point P is up along that line. The other side for the chimney is here, and that's going to be up a height of 25. So 25 would be here. The very top of that now is point P. So up here is our point P. And that's the first part of that question, or the first part of the question. So this height from here up is 25 millimeters, and up in this top right hand corner now, that is point P. So all I've done here now is I've just skipped forward past a few pieces, looking at how we find each of the points. So P1 is across 95 horizontal to the top point A. P2 is going to be down 110 below that and out 50 millimeters from E. P3 is 86 millimeters horizontal from P1, and it is going to be 60 millimeters below it. And then we're finding O. O is 30 millimeters below P3 and 150 horizontal from P2, and the line L then is drawn next to that. So this is our line OL. The length of this line is not important, it just needs to be long enough that from O to P3 that radius will touch off that line. Okay, so next thing what we're going to do is we're going to start part B of this, is determine the image of the logo under each of the above transformations. And our first one from P to P1 is an axial symmetry. So we have now set up our question and we have P and P1. So here to here. I need to put in an axis. P1 does not contain the axis. Our axis is going to be halfway between the 2 points. So our axis is going to be coming down along here somewhere. So to find my axis, what I'm going to do is I'm going to join P to P1. And as it's an axis, it's going to be halfway between the two positions. So I'm going to bisect the line, and the bisector that I end up with is going to be my axis. So P to P1, swinging my arc, form the bisector, and this bisector here is my axis. What I'm going to do next is each point is going to move perpendicular to this. So I have a number of the points already. I've labelled A to F. I also have point P, and it's no harm in labelling some of the other points that we're going to need also. So I can have Q up here in the top right corner, and maybe S down here. Okay, so P, Q, S, and we're also going to need R down here, which will be the center of that one. So this is quite a number of points that need to be moved, but they're all moved the same way, so it'll be something that we can do quite easily. So what we're doing now is we're going to take each point in turn and move it perpendicular to our axis. So when something moves, if this is my axis here, this is the shape, everything is going to move perpendicular across it. So all the points are going to come, or all our lines from our points are going to move perpendicular to the axis. So we can set up our set squares, and maybe only take 2 points at a time. Any more than that it might get a little bit confusing. So taking point Q, going to project that across, and let's say point S, taking that one also. Now I'm going to set my compass, measure from the axis to the point that I want to transform. So axis to Q, same distance on the other side. This is Q1. From the axis to S, equal distance on the opposite side. This is S1. Okay, so going to do next few points. So again, line it up the same way. So perpendicular to the axis, point A is coming across here. Point B, I'm going to take C as well. Okay, so A measuring from our axis across to the point, same distance on the other side, and this is A1. S I have, B across, that's B1, and C1 here also. C1. Now I can also take R, that goes through the same line that C did. So measuring R. And the same thing happened for F. This is F1 and R1. And then I'm just left with two more that need to come across, which are D and E. So you can also do it this way if you wish. So this is 31, so I'm going to have 31 out on this side. D1 and 4 mil, so 4 mil on the opposite side also. And E1. Now that I have all my points, it's just a matter of joining up all of the points to form the correct shape. So D, R, and E join together, so D, R, and E also join together here. D1 joins to C1, so that's going to be the same here. C joins to B, so C1 is going to join to B1. B1 to A, B to A, and it goes through S, all going well, if you're accurate. And A to F on this side also. And finally F to E. So that gives us our basic shape for the hexagon. A few other bits now that need to go into this, so I need to find S. I have S, that joins to Q. So S is going to join to Q here. Q joins to P. And I need to locate my points in the center. So to get my points in the center, I'm going to do what I did previously. A joins to E. So that's going to give me that one. Just like A joined to E over here. B joins to D. And F to C. That's going to give me the points that I'm looking for. So that gives me enough to draw my arc now. So this point goes around that way. And with S as the center for the second one, that's also coming up here. Okay. And the final part of this then was where a line joining the two centers, S and R, intersects there. Joining that to P is going to give me the final bit that I'm looking for over here. So that then gives me that part of the question. So that's our first part of this axial symmetry from P to P1. So just recap, took P, drew a straight line joining it to P1, bisected the line between them. Okay, so when I bisect that line, that gives me my axis. The bisector is the axis, and all points are going to move perpendicular to that. They're going to be equal distance on either side of the axis. A to the axis is going to be the same as A1 to the axis. From S to the axis will be the same on the opposite side, and so on. So let's now have a look at the second transformation that needs to happen, and just have a look at the question once again. So the second part of this is a translation from P1 to P2. We've already located both of those points, so P1 to P2. So we'll just swap back again. So P1 is up here, P2 is down here underneath it. It is a translation, which means it's going to move without changing direction, without changing size. It's not going to flip, it's not going to turn, it's not going to do anything like that. All it's going to do is start off up here, end up down here. It doesn't twist, turn, do anything else. So to start this one, again we're going to set it up much the same way that we did our axial symmetry. We're going to join P1 to P2. So P1 to P2. Now this is an important line. It gives us two bits of information. It tells us, one, the direction that everything is going to be going in. So from P1 to P2, all other points are going to move the same direction as that. So they're all going to move parallel to it, so coming down along parallel. Second thing it tells us is the distance that each point is going to move. So if the shape can't change size, they all have to move this distance. So we're going to measure this distance with our compass, and each point is going to move the same distance. So let's get started with that. So working around in a circle, maybe I've already got P1. Now I'm going to take Q1. So P1, that's going to come down this way. Again, maybe just take a few points at a time, don't take too many. So I can set my compass up once now for this, so from P1 to P2, they're going to move the same distance and direction. So just test it, make sure that it's correct. Q, put the pointer compass on Q, and swing it down here. That's now Q2. Just put it on B1 next, from B1 down to B2. Okay, and continue on doing the rest of the points in this manner. So line it up every so often, make sure you're still going correct. That's point A, D, and R. So same distance, same direction. R and D1. So this is R2, D2, and A2. Still a few more points that need to be moved. So E and F have to come down this way. And C, which I have the point for already. And I have S up here that needs to go. So from each point, mark its position. This is S2, F2 up here, and E2. Now, as I have each of the points, again, what I can start doing is I can start joining them all up together. So E and D join together and they intersect R. E goes to F. So the rest of this now is much the same. I'll skip to point C1. So that's C2. So again, all I'm doing is redrawing the shape, given the information that I have already. So each point joins up together. So B was joined to A initially up here, so B joins to A, so B is joined to A down here also. A to F2, Q joins to S, Q also joins to P, and then we need to locate our point down in here again. So we're going to do the same thing that we did a while ago. Join F2 to C2, just like I did up here and up here. A to E, and B2 to D2. Again, now I can draw my arcs. The arcs here, so I have R, I have my arcs, and with these arcs, it's going to give me the positioning of each one. Okay, so that gives me my arcs, I can darken them in. And when S is joined to R, this point through P gives me the correct position for where it intersects up here. So that's my translation. So again, just a quick recap. We've taken the distance from P1 to P2, drawn a straight line between them. That gives us our direction. So all points are going to move parallel to that one. So everything's going to be parallel to it. All our lines going across. Parallel user sliding set squares. Second part then that it gives us is the distance that it moves. So P1 to P2 is a fixed distance. Q1 to Q2 is going to be the same. B1 to B2, they're all going to be the exact same distance as P1 to P2. So the next part of this, again looking at our question, is a central symmetry from P2 to P3. We already have our points located on our page. We set them up initially, and I'd always recommend you set them up at the very start. So P2 to P3. It's important to remember now also that P3 is not the center of symmetry. P3 is part on the object, just like P2, P1, and P were. So our center of symmetry is going to be somewhere in between P2 and P3. To find that, we're going to do the same thing that we did for our axial symmetry. And what we did for our translation. We're going to join the two together, so P3 to P2, and our center of symmetry is going to be part way between it. How far between it? Exactly halfway. So we're going to bisect the line P2 to P3. So extend over halfway, swing your arc. Do the same thing for from P3. cuts the arc in two places, and let's join these lines together. So this point here now, that is our center of symmetry. Okay, so all points are now going to have to pass through that one just to as our center of symmetry. So it's really important that you keep your pencil sharp when you're doing stuff like this, because if you have a very blunt pencil, your lines are not going to go through it, they're going to start going off at different angles. So this one can get quite complicated fairly quickly. So what we're going to do is I'm just going to take one point at a time. So point Q next, draw it through the center of symmetry, make sure it goes through it, measure the distance from the center to point Q, and same distance on the opposite side. Okay, so this is Q2. From S now, same idea. So it goes through. So Q, center symmetry to S, equal distance on the opposite side, S3, Q3. So from B through our center of symmetry, out the other side, again we're measuring, it's equal distance either side of the center of symmetry. So from the center to B2, equal distance out to B3. So I'm just going to jump ahead now and get a few more of these points drawn. So I've just found all my points doing the exact same method that I had been doing, joining from C, or from my point, through the center of symmetry and extending out, copying the distance from the center of symmetry to my point, marking the same distance on the opposite side, just to speed things up a little bit. So now all I'm going to do is I'm going to join each of these points up. So they should all join up accurately. If they haven't, you've gone somewhere slightly wrong. That could be down to a number of different reasons. It could be down to your compass being a little bit springy and bringing the distance in more than it should. It could be from not a sharp pencil, or from just general inaccuracies when you're drawing. So all of those points are now joined up. P goes to Q. Now I just need to be careful here that I join the correct line up, as it can get quite messy quite quickly. So this is Q. Which joined to S. And C was joined to F here, so I can copy these on. These two are also joined together. Here and here, giving me my arc for the center, starting at this point. And same on the opposite side. This point joins up, and that again gives me the final part of that there. Okay, so central symmetry, kind of the messiest of them that are there. Pick my point, so F2, join it through the center symmetry and extend, and it's going to be equal distance on the opposite side. So from the center to the point, same distance on the opposite side. From S to the point, same distance on the opposite side. Take your time with this part of it, it is one of the more tricky parts of it. So the final part of this question is the rotation of clockwise about point O until point P3 reaches the line OL. I'm going to do that in a separate video just so that I can focus in on that much of it a little bit more. So just for now, this is the question with 3/4 of it finished. We still have the rotation to do down over here with center point of O.